Okay, thank you. This is Paul Gilman. Welcome to the Modeling Biopower Projects with SAM webinar. We have about an hour scheduled. We may go over a little. I think we reserved up to 2 hours for this session, but we hope to keep it down to an hour. So this is what we'll be covering today. Basically, we've got two sections. We'll start off with a short PowerPoint presentation covering general information about SAM, and then we'll spend most of the time live in SAM demonstrating the biopower model. We're making a recording of this session, which will be available for download on the SAM website, and along with a set of speakers notes. And I'll show you that website later on. So let's start with introduction, the general introduction to SAM. SAM is a free computer program that basically does two things. It calculates the hourly energy output of a renewable energy system, and then it calculates the cost of energy of generating electricity with that system. SAM consists of, at the highest level, a performance model, which makes the energy output calculations, and a financial model that makes cash flow calculations necessary for the cost of energy. So conceptually, think of SAM as sort of two parts, a performance model and a financial model. Those models require lots of inputs, as you'll see in a moment. The input variables are populated with default values, which are designed to help you get started. Keep in mind that these default values are just sort of sample values that we've chosen somewhat arbitrarily. They don't represent values that have been approved by DOE or by NREL. They're just to help you get started with the analysis, and we'll see these values as we look at the interface. So in general, SAM models a range of renewable energy power systems. You can also model a conventional power system for comparison with the renewable technologies. It's designed to allow you to evaluate and compare different options. Because each of the performance models is in the SAM platform, you have a consistent basis for making comparisons across technologies. SAM calculates economic metrics like LCOE, levelized cost of energy, net present value, and payback for projects in different markets. It calculates a bunch of results, which it displays in graphs and tables that we'll see. And then it also allows you to do some more advanced analyses like parametric and uncertainty analyses. This is a list of the technologies and markets that SAM can model. Photovoltaics, a range of CSP technologies, solar water heating, wind, geothermal, and what we're talking about today is biomass. All of those technologies are electric generation technologies except for the solar water heating. SAM is designed to model electric power systems. The CSP models don't really handle thermal applications. So SAM is primarily an electric power generation model. And then on the financing side, SAM can model projects for residential, commercial, and utility scale markets. And that involves you have to provide SAM with installation and operating costs, and then information about any incentives and power prices. The key outputs of the performance model are hourly energy production in kilowatt hours, and SAM adds those values up to report monthly and annual values as well. And then other technical metrics like capacity factor and system efficiency, overall conversion efficiency. And then on the financing side, the key outputs are levelized cost of electricity, so the cost of generating electricity over the life of the project. And then depending on the market or on the financing option, residential, commercial, so on, there are other outputs like payback, net present value, and a year-to-year cash flow. SAM is funded by the Department of Energy. Most of the development happens at NREL, the National Renewable Energy Lab. We also work with Sandia National Labs. SAM is used by a range of different kinds of people. Project developers, for example, use it for feasibility studies, for project-level analyses. Partners in a project use SAM as a benchmark. For example, different partners in a project may have their own internal models that they don't want to share with other partners, and they'll use SAM as a kind of a collaboration tool. So they'll use their own internal models to generate inputs to SAM, and then run SAM and use SAM to discuss the general parameters of the project. It's used for research. It's also used, the parabolic trough model in SAM is used for plant acceptance testing. And then it's used by the Department of Energy for evaluating its internal programs. A lot of people work on SAM. This is a list of some of the folks on the SAM team. This is a screenshot of the website where you download SAM. And this is just to let you know that to get SAM, you have to register. It's free to download, so there's no cost. But we do ask you to complete a short questionnaire. And then once you've registered on the website, you can come to the website to download the software. And we typically SAM is in constant development, and we typically release about 2 versions a year. So every 6 months or so, you can come to the website and download a new version. When you register to the website, you're also added to a mailing list where we use the mailing list to send out announcements about new versions and also about webinars and other SAM-related events like this one. We have a couple of resources for getting help using SAM. One is the online help system, so that's built into the software. You can use the help menu, or in Windows, press F1, or on a Mac, press Command ? To open the help system. Here's the screenshot on the right side of the screen here. So that's kind of sort of user reference guide built into the software. And then the support forum on the SAM website is another resource. It's searchable. If you have questions that aren't addressed in the help system, you can post them on the support forum, and the SAM team monitors the support forum and answers questions there. So a couple of places for help. All right, so that's the general overview of SAM, and now we get to the main topic of today's session, which is simulating biopower systems in SAM. I wanted to start off with kind of a block diagram of the kind of system that SAM can model. So SAM models biomass combustion for electricity generation, and the system consists of these main systems. There's a sort of feedstock handling, which models things like the drying of the feedstock and so on, and then a combustion system, which is where the feedstock is combusted to generate steam that drives a conventional steam turbine, which drives a generator to generate electricity. And then, so those are the 3 main components of the biopower system in SAM. And then it also handles parasitic loads that are required to run various fans and electric motors in the system. Jenny will be getting into more detail about this, but just wanted to set the context for the model here. The current version of SAM does not model gasification or anaerobic digestion for now. That may change in future versions, but for now we've just got a combustion system. So in addition to simulating a power system, you can use SAM for more advanced analyses. I have some screenshots showing some results here to give you a sense of what that means. The parametric and uncertainty analysis capabilities basically allow you to assign multiple values to input variables, so that you can look at results for over a range of values. And you can use that to answer questions like, how does the LCOE vary with feedstock delivery cost? So this graph down here in the bottom left shows the results of a parametric analysis on feedstock delivery costs. And we can see that as the cost increases, we can see by how much the LCOE increases. And then this tornado graph and histogram are results from an uncertainty analysis where instead of assigning discrete values to the variable, you're assigning a range of variables using a distribution that you can specify. And you can use these kind of graphs to look at sensitivity of different inputs to a given output. So we can say, what design factor is the LCOE most sensitive to? So we could have a whole session on these advanced analysis techniques, but I just wanted to introduce them to you here so you'd be aware that you can use SAM for this kind of analysis. There's other advanced features. Excel Exchange allows you to calculate the value of input variables in SAM using an Excel spreadsheet. SAM has a built-in scripting language that's sort of analogous to VBA in Excel. So you can write your own little program within SAM to control the value of inputs, to manipulate or to control simulations, and also to extract results and export them to text files. And then there's also an application programming interface for those of you who are programmers that allows you to control SAM from an external program that you write in a programming language. There are also some other advanced modeling features in SAM that you can explore or help in the website to learn more about. All right, so that's the end of PowerPoint. Let's move on to SAM. And this is what let me create a new file here so you can see what SAM looks like when you first start it. This is the welcome page in SAM. And let's see, I guess let me pause for a moment here and let folks know we've got somebody monitoring the Q&A chat window. So if you've got a question, feel free to type one there. We're also going to provide about 10 minutes at the end for Q&A. And so we've got about 40 people online, so I don't want to interrupt too much with questions as we go. So during the session, until we get to the Q&A, if you've got a question, please use the Q&A chat window to type your question, and we'll either answer it by typing back, or my colleague will interrupt me to answer the question by voice. Okay, so this is what SAM looks like when you open it, and we're having some trouble with our web server at the moment. So this notification area normally shows you some announcements. They're now available on a website if you click the Here link. So we've got an announcement about these webinars. But we'll fix that soon. The announcements will be back in this window. But to get started with an analysis, the first thing you do is type in the name of your project. So I'm calling this one Biomass Power Demonstration, and then click Create New File. That opens the Technology and Market window, and this is where I choose a technology and a financing option. So here's a list of all the technologies that SAM can model. we're looking at biomass power. And then this is a list of the financing options. We've got the commercial financing option. That's for the customer side of a utility meter. And then the commercial PPA and the utility financing options are for projects that are on the power generation side of the utility meter. So commercial, we're going to look at a commercial example here. So I'll choose that one. This list expands for even more financing options on the utility side of things, just so you know. Okay, so I'll click commercial, click OK. And that SAM creates a case in the SAM file. And the case in the SAM file is analogous to a worksheet in an Excel workbook. I can add another case to the file. For example, I could add a PV case if I wanted to do a comparison between biomass and PV for some reason. Then I get two tabs in the case in my file, and I can switch between them to do comparisons. I'm not doing a comparison for this demonstration, so I'll delete the case by clicking X here and go back to my single case of Biopower. The buttons along the left side here are navigation buttons. When you click a button, it displays an input page. And then when you've specified your inputs, then you click the Run button, this green arrow button here, and SAM does a bunch of calculations and displays the results page. So I'm going to cover the financial inputs very briefly, and then I'm going to switch over to Jenny, who's going to talk to you about the Biopower model itself. I'll start with the climate page here. So this is where you tell SAM where the project is. And for the Biopower model, what this SAM uses the data from this weather file to model the steam cycle, so the power cycle, and also to do some modeling of the feedstock, moisture in the feedstock. So if you're familiar with SAM from the other technologies, the climate page is what determines the renewable resource available to the plant. That's a little different for Biopower. For Biopower, the climate page just provides temperature and humidity and the ambient conditions that are used for modeling of the power cycle and feedstock. Jenny's going to talk about the feedstock resource, which is the renewable resource available to the plant. The rest of the buttons, as you move down the left side here, are inputs for the performance model. So Jenny will be going over those. The input pages down here are for the financing model. So we'll start with the utility rate page. So this applies only to projects with either residential or commercial financing. And this is where you define the power price. So this is for this commercial system is for a project on the retail side of the utility meter. So we need to tell SAM how much it costs to buy and sell power. And you can use this search for rates button to search a database of U.S. utilities. So I'm in Portland. Type Portland in here. Here's my utility. And SAM goes to this website and gets the utility rates for my utility. So if this project it's a commercial project, maybe it might qualify for this commercial TOU rate structure, then I can automatically download it from the website. You can also specify your rates by hand here. So you can either download them from the website or specify them by hand. These utility rates only apply for commercial and residential financing. If you're modeling a utility scale system, then you specify a PPA price. So it's a different financial model that we're not going to talk about today. But you can read more about in help or on the website. The financing page is where you specify the general financial parameters of the project. So the analysis period, the number of years in the project, inflation rate, tax rates, the loan terms, depreciation if the project qualifies. And then SAM models two kinds of incentives, tax credits and payment incentives. So the tax credit page is where you specify an ITC if the project qualifies, or a production tax credit if the project qualifies. And then on the payment incentives page, you can model a wide range of incentives that are payments to the projects. So investment-based incentives and capacity-based incentives are payments that are made in year one of the project. And then production-based incentives are payments that are made annually based on the amount of electricity that the project generates. And then annual performance is where you can specify a degradation rate or availability factor if it applies to your project. So that's a very quick introduction to the inputs for the financial models. Now I'll pass the baton over to Jenny, who's going to talk to you about the performance model.